Download this code from codegive.com, link in the description below. OK, let's dive into a detailed Angular 17 tutorial focusing on folder structure and architecture. We'll cover the recommended practices, key components, and provide code examples to illustrate each concept. Angular 17 Folder Structure and Architecture, a comprehensive guide. This tutorial will guide you through the recommended folder structure and architectural patterns for building robust and maintainable Angular 17 applications. We'll cover 1. Project setup * creating a new Angular project using the Angular CLI. 2. Recommended folder structure * a detailed explanation of the standard directory layout. 3. Architectural patterns * understanding modules, components, services, routing, and state management. 4. Code examples * practical code snippets to demonstrate the concepts. 5. Best practices * tips for maintaining a clean and organized code base. 1. Project setup. First, make sure you have Node.js and npm installed. Then, install the Angular CLI, command line interface, globally. Now, create a new Angular project. You will be prompted. * Would you like to add Angular routing? Choose yes, why? * Which style sheet format would you like to use? Choose your preferred format, example SCSS, CSS, SAS. 2. Recommended folder structure. The standard Angular folder structure, promoted by the Angular Style Guide, emphasizes modularity and separation of concerns. Here's a typical structure. Let's break down each directory. *src / this is the core of your application. *app / contains the main application modules, components, services, and routing configuration. *components / holds your application's components. Each component should have its own directory. *home / a component representing the home page. *home.component.ts, the component's logic, TypeScript code. *home.component.html, the component's template, HTML. *home.component.scss, the component's styles, SCSS/CSS. *home.component.spects, the component's unit tests. *about / a component representing the about page. Same structure as home /. *services / contains reusable services that provide data access, business logic, or utility functions. *data.service.ts, a service for fetching data from an API. *auth.service.ts, a service for handling authentication. *models / defines the data structures, interfaces or classes, used in your application. *user.model.ts, represents a user object. *product.model.ts, represents a product object. *approuting.module.ts, configures the application's routes, navigation. *appcomponent.ts, the root component of the application. *appcomponent.html, the root component's template. *appcomponent.scss, the root component's styles. *appcomponent.spects, the root component's tests. *appmodule.ts, the main application module, which imports and declares the other modules and components. *assets / holds static assets like images, fonts, and other files. *environments / contains environment-specific configuration files, example API URLs for development and production. *environment.ts, Development Environment Settings. *environment.prod.ts, Production Environment Settings. *index.html, the main HTML file that bootstraps the application. *main.ts, the entry point of the application, which bootstraps the app module. *polyfills.ts, contains polyfills for older browsers. *styles.scss, global styles for the application. *test.ts, configuration for the testing environment. *angular.json*, the Angular CLI configuration file. Controls, build options, styles, scripts, and more. *package.json*, lists the project's dependencies and scripts. *config.json*, TypeScript compiler configuration file. *readme.md*, a description of your project. 3. Architectural patterns. Now, let's discuss the key architectural patterns in Angular. *modules. Modules are containers for components, services, and other modules. They organize your application into logical units. App module is the root module. You can create feature modules, example auth module, products module, to encapsulate related functionality. *components. Components are the building blocks of your UI. Each component controls a portion of the screen and handles user interactions. *services. Services provide reusable logic that can be injected into components. They are typically used for data access, authentication, or other business rules. *routing. Routing enables navigation between different views, components, in your application. The router module is used to configure routes. *state management. For complex applications, state management libraries like NGRX or Akita can help manage application state in a predictable way. *HTTP client. The HTTP client module enables your application to make HTTP requests to APIs. Dependency injection. Angular's dependency injection system allows you to provide dependencies, like services, to components and other services. 4. Code examples. Let's create some simple examples to illustrate these concepts. Example: a simple component, home.component.ts. home.component.html. Example: a simple service, data.service.ts. Example: using the service in a component. about.component.html. Example: routing, approuting.module.ts. Important: update appmodule.ts. You need to import HTTP client module and approuting module in your appmodule.ts. Add router outlet to appcomponent.html. To display the routed components, add the router outlet directive in your main appcomponent.html. 5. Best practices. Keep components small and focused. Each component should have a single responsibility. If a component becomes too large, break it down into smaller, more manageable components. Use services for reusable logic. Avoid duplicating code in multiple components. Extract common logic into services. Follow the Angular style guide. Adhere to the recommended naming conventions, folder structure, and coding practices. See the link at the beginning of this tutorial. Use lazy loading. Lazy loading improves the initial load time of your application by loading modules only when they are needed. Configure routes to lazy load feature modules. Use type safety. Leverage TypeScript's type system to catch errors early and improve code maintainability. Write unit tests. Test your components and services to ensure they function correctly. Use a linter. Use a linter, like ESLint, to enforce coding standards and identify potential issues. Angular CLI projects come with a default linter setup. Use a formatter. Use a code formatter, like Prettier, to automatically format your code. Version control. Use Git or another version control system to track changes to your code. State management, advanced. For larger applications where managing complex data flow and application state becomes challenging, consider using a state management library such as *NGRX*, a reactive state management library inspired by Redux. Akita*, a simpler state management library that's easier to learn and use. *RxJS*, utilize reactive programming with RxJS for handling asynchronous operations and data streams. Conclusion. This tutorial has provided a comprehensive overview of Angular 17 folder structure and architectural patterns. By following these guidelines, you can build well-organized, maintainable, and scalable Angular applications. Remember to consistently apply best practices, use a linter, and write unit tests to ensure the quality of your code. Good luck.